Thank you, Hugh. I think Frederick is joining. First of all, I thank everyone for joining this session for the Red Hat Research Days. And thank you, Frederick, for presenting in this event. Frederick is the Director of Software and Application Innovation Lab at Boston University. He leads a team of software engineers, and they are responsible for the design, development, and management of various software projects in support of computational research efforts at Boston University. Today, Frederick is going to be talking about MPC, and I think his audio should be working. Frederick, can you hear me? Yeah, I think first I wanted to ask you to kind of introduce the problem for the audience, right? MPC, a quick overview, and what is it about?
Sure. So this will not be a very technical presentation. This is more our experience of building and deploying a web-based MPC platform over the past 5 years. We are active in a more technical space of MPC, but as I'll touch upon in the presentation, a lot of work is being done on the technical side that doesn't see a lot of traction in real-world usage and deployments. And this is actually one of the few applications of MPC that has been deployed with actual users, which is just some of the lessons that I wanted to talk about that we learned in that process.
Okay, awesome. Can you highlight? I know you're going to go into more details in your presentation, but if you have to pick like a couple of use cases, applications that would that you have seen derive value from this concept.
Sure. So MPC in general, as Adam mentioned, is really about, Adam in the previous conversation, is really about being able to compute over shared data without having to actually share your data. So I think any time where you have data that's private to you, but you want to be able to compute over joint data with others without revealing your data, this is useful. For the platform that we built specifically, it's been more about smaller data sets, but with bigger impact, hopefully. And we've been very active in the social good space, dealing with pay equity, dealing with bank fraud, dealing with sexual assault, et cetera, et cetera.
Okay, awesome. Just to bring some personal perspective here, could you highlight, what got you interested in this work?
I rolled into it as one of the first tasks that I had when I was a software engineer at the Software and Application Innovation Lab. It just happened to be one of the first projects. And it resonates with me because I work in academia, but I like having, being kind of at the forefront of where academia meets private industry and being more on the applied side. So, this is great because we actually have been able to deploy this, which makes this one of my favorite projects that I've worked on.
Awesome. I'm also interested in, from a technical innovation, technical challenges aspect, right? Depending upon, where the technology stands today, what would you think are the, maybe, just pick a couple of areas of innovation challenges that you see in this getting adopted?
I would say mostly on software engineering best practices and tooling. I think performance for the past couple of years at least has been good enough for a lot of use cases. But what's lacking is, we don't have, it's in the works, but things like NumPy with MPC, TensorFlow with MPC, and the kind of tools that exist elsewhere in data science, for example, that don't exist yet in MPC. A lot of it is having to learn new languages, new frameworks, new technologies, and also having to have some affinity for the crypto behind it, which you don't need in different programming paradigms as much.
Okay. I think the last question I have is, whenever we talk about privacy, right, the things that enterprise customers always think about is regulatory compliance, right? They think about GDPR, HIPAA, etc. So I did do some research based on the pointers you gave me to kind of understand how, the way this technology is applied, it is keeping those regulations in mind, but kind of avoiding the exposure of private data, right? So, but I wanted to get your perspective on that for the audience.
Yeah, we believe so. I think it's kind of difficult in the academic setting to really test that hypothesis. As far as I'm aware, no one has been sued under HIPAA laws or regulations or GDPR laws and regulations saying, these don't apply to me because I use MPC. I think it'll be interesting when that happens, if it stands the challenge there. But it is something that we hypothesize at least would be a solution for some of the privacy regulations that are out there.
Awesome. At this point, I'm going to turn it over to you so you can present what you wanted to share with the audience. And for the audience, if you want to type your questions in the chat, we will get to them once Frederick is done here. And then we also have a breakout session for more questions.
Perfect. Thank you. Okay. So I am Frederick Jansen. I'm the director of the Software and Application Innovation Lab at Boston University, and also concurrently CTO at Nth Party, which is actually a startup hoping to commercialize some MPC solutions. Very briefly, for those who don't have the background, what is MPC? It's a subset or a subfield of cryptography that allows you to compute over private data while revealing the output. So as Adam mentioned in the previous presentation, it does not make any guarantees about what you can infer from that public output. If the calculation that you choose happens to be a min-max function, then you will reveal exactly one row of your input. So you have to be careful, what kind of queries you run. And it exists in a field of others, privacy enhancing technologies, and is really complementary to a lot of them, including differential privacy, which, as Adam mentioned, is more at the row level of protection. We talk about the entirety of the computation in the case of multi-party computation. And specifically what we've been interested in for the most part is MPC for social good. So the project that I'll be talking about for the platform that drives this project is the Boston Women's Workforce Council, the Pay Equity Project, as well as the Greater Boston Chamber of Commerce Economic Inclusion Project. There are others that I've enjoyed working on. Currently in active development is a private set intersection project for bank fraud detection, so that banks can share certain pieces of information under MPC. And then Project Callisto, which had to do with detecting serial perpetrators of sexual misconduct, which I thought was a great project as well. A little bit of history. So MPC was discovered in the 1970s, late 1970s, early 1980s. And then 30 years later is really the first time that anyone uses it in practice with the, in our world, very famous sugar beet auction, 2008. A couple of years go by, 2014, there's a simulation. I think we could call this a deployment. I'm not sure if any of the outcomes are actually used. And then it's a string of deployments by, my very, very small group, which is somewhat surprising given that, it is an active field of academia and there are companies that are active in this space. And it's also somewhat sad in a way that this really useful technology, it's really taken more than 30 years for people to find usable ways of deploying it. It is 2 years ago. What's really missing from here, 2017, Google started using secure aggregation for predictive typing. So it's a big deployment. But really, up until recently, at least more than half of the deployments that I know of were done by our team worldwide. Right now, the landscape looks, thankfully, a little bit different. These are all members of the MPC Alliance that are either building MPC solutions, and these are all private companies that are either building MPC solutions or are using MPC in their workflows. So I'm very happy to see that there is more traction for this technology. Kind of setting the stage of the MPC platform that we worked on. So a number of years ago, this is early maybe 2012, 2013, Mayor Menino started the Office for Women's Advancement in Boston, and had the goal of making Boston the premier working place for women. One of the pillars of this endeavor was measuring the wage gap and closing the wage gap. And for that to be effective, they required data of Boston employers that would show how large the wage gap actually was. So a number of companies signed on to this compact, and when it came time to submit the data, they kind of ran into a snag because they had identified a trusted third party that would be collecting all of this data in the clear, and they backed out and they said, well, you know, this looks like a legal liability to us. If we get hacked, if we leak the data, we're going to get sued, and we really don't want to get sued. And some of the companies that were participating were hesitant. You know, they were saying, well, this is confidential. This is, you know, we're submitting salary data. We really don't want our competitors to know exactly how much we pay our employees, or if we have a wage gap or not. And so it wasn't really going anywhere until my boss at the time, Oscar Stavros, said, oh, actually, I know of this technology from my days in college that was invented in the 1970s, and I think MPC is actually what we want to use here. Okay, so we've identified that MPC is a solution, but now the goal is, how do you convince people that they should actually sign on to this? And I would say that half the battle has been communicating MPC to non-technical people and explaining it to them, not just explaining the concepts of MPC, but also giving them a feeling and an intuition for how MPC works in such a way that they trust us that we can perform these computations, and that we're not talking about what they might suspect is access control. You know, we get questions along the lines of, you know, we trust that you say that you're not going to be able to view this data, but can you look at the data? You know, maybe my data is encrypted, but when you're performing this computation, you have to decrypt the data, right? How else are you going to be able to do this? Or, you know, if your data does leak, what are the implications in terms of liability? You know, are we going to get bad press if you get hacked? What's the cost of us to participate? What's the IT expertise that we need? This all sounds complicated. You know, what do we have to do to build these kinds of systems? And then the second question is, can I legally participate? You know, maybe my data is covered by or encumbered by HIPAA compliance. Maybe I'm a government. Maybe I worry about FOIA. Which lawyers have to be in the room? Are we signing an NDA? What's the legal agreement looking like, you know, for what you are legally allowed to do with our data? So a lot of our communication has been really to answer these questions and to make sure people understand that these, you know, you might have concerns about MPC, but these are not the concerns that that you should be having. And a very common question that we get is it blockchain? Which the answer to is no. So we try to explain. This is one of the slides of our presentations, or one of the earlier versions of the slides, on how we explain the concept of MPC. You know, you start with your data, $10, you split it into 2 shares, you send 1 share to one party, you send the other share to the other party, they add up all of their shares locally, send over the result to the other party, and if you do, you know, the total sum, you end up with the total of the input parties without revealing any of the individual data points. So this worked fine for a while, until some astute observer remarked that, aren't you really leaking the lower bound here? Like, if I send you a 5, doesn't that mean that my total value is never going to be less than 5? And we said, yeah, that's true. This is maybe a bad example. But we don't really want to explain finite field arithmetic. Or maybe we do. So what's an object, or what's an analogy in real life that could explain finite field arithmetic? So we thought, if you're over 30, you've seen an analog clock before. And you know, this wraps around, and this hopefully gives people an intuition of how numbers roll over and how you deal with bounds in MPC. So we used this for a while to explain MPC to people, and the math works out, and people seem to understand that, you know, this is how you deal with the bounds problem, at least the lower bounds problem. But then, for some reason, even though everything works out. People don't really have an intuition for doing math on clocks and adding up clocks together and subtracting them, and it works, but they don't really feel like, they couldn't really quite wrap their head around why it worked, versus this version, it was very clear what you were doing. So then we finally decided, let's keep additive secret sharing. Let's do negative, instead of splitting it into 2 shares, let's just add a mask to the data. And so now you have your actual data, you add a random value to it, can be positive, can be negative. So the length of your bar chart here no longer corresponds to the actual value of the data. But if you send the masks to one party, you send the mask data to the other party, you add them all up, and you get the same result. So this is typically what we use these days when we explain one of the concepts of or one of the building blocks of MPC. And then we have our protocol diagram, which is what we show to actually, this is maybe more for IT departments, but this is how we are party 1, Boston Women's Workforce Council is party 2, and this is where all the data goes, the masks, the random mask, we encrypt the masks, et cetera, et cetera. Other considerations in communication is that we typically only explain additive secret sharing, but it's not actually what we use anymore. We used to rely on additive secret sharing. Now we use Shamir secret sharing, and we support general purpose MPC. But we tell people, now you understand how MPC works, and you should have a sense of how it's possible. Trust us that we can do more using or relying on the same privacy guarantees that we told you about before. And if that isn't enough, here are some large companies that have signed on in the previous years or have signed on in this year. And we refer to State Street, we refer to Partners Healthcare, to Boston University, to MIT, and say, maybe you don't trust us, but you might trust these other companies that are participating. And that typically has worked out pretty well. We do have other variants of presentations, like for example, for the for Project Callisto, we do show how Shamir secret sharing works, but it's for a very specific audience, and it's typically not for the web-based platform. If it's an in-person setting, we have used a different example, which I'm a fan of, and it's kind of a round-robin style average birthday calculator. So you lie about your birthday to the person who's sitting next to you, but you remember by how much you lied, and you spread that lie kind of around, like the next person does the same thing and adds it up until you get back to the first person. And then you do a second round of communication, but you all subtract by how much you lied about your age. And in the end, you end up with the total age of everyone, which you divide by the amount of people in the group, and no one has revealed their own age. This is an example that resonates well with people and is easy enough that you could do it with your kids, and seems to work well. And then we also have, there's always a lot of training sessions and handouts for data submission, just because I'll touch upon this later in this talk. We have made mistakes, and it's much more difficult to recover from them past the MPC point, because we don't have the data and we don't see the data. So we spend a large amount of time training people on how to use the platform, what kind of data to collect, how to collect it, how to submit the data, even though we wish we didn't have to, but it seems to be worth the cost. And one final thing, verbiage. This was especially difficult when we started doing this. We would talk, for example, about, oh, you upload your spreadsheet, and then someone would remark, upload, I thought we weren't giving you the data. And we said, okay, well, upload maybe is not the right word. We're not really sure what the right verbiage is when it comes to MPC. But we've used, you participate in a computation. You don't actually upload your data. And that seems to work well with people. So at this point, let's assume, we've got the communication down. People agree that MPC is the right solution and that they'll participate. Now we actually have to build something. Or we don't have to build something. Maybe we can use something that already exists that's off the shelf and just adapt it to our needs. Problem is, even at the time, 5 years ago, commercial solutions did exist. And we spoke to a vendor, for example, we explained their problem to them, and they said, oh, we have the perfect solution for you. We will give you a VM. You will add your algorithm to this VM. You go to your participants and you tell them to deploy this VM on their cloud environment. They connect it to their data storage. Then they go into their firewall, open up a bunch of ports, and then when everyone has done this, at the same moment, we'll flip a switch and the computation will happen. It will be really fast, and then you get the results of your MPC computation. And we said, well, that's going to be an issue because we have banks signed up, and no self-respecting bank or hospital or even a large university is going to be installing binaries on their cloud environment. And the other set of folks that we're working with are startups. They don't have a cloud environment. They don't have the technical knowledge. They don't have an IT department. They can't set up VMs. So we asked them, can we do this in the web? And they said, why would you want to do this in the web? That's a stupid idea. So we decided to build our own web-based solution, which, if you think about it, the browser really is the one piece of unifying software that every person has, and that every company, everyone from HR to IT to sales will be able to work with. So we set out and built a browser-based solution, the first version of which was not very good. We affectionately call it our beta test because it had some issues. It worked for the most part, but data validation wasn't its strong suit. So this was built very quickly over the course of a weekend, and we deployed it once and then made fixes to it. Over the years, we've ended up with a completely different solution, or in terms of UI, a different experience for the user. So now participating in MPC is as simple as you click on a link, it fills out your session key and participation code, you drag and drop in the template that you filled in before, you hit submit, and that's it. You've participated successfully in an MPC computation. You can resubmit as many times as you like if you've made a mistake. It's all drag and drop, supports every contemporary browser. We've done extensive user testing using Amazon Turk to make sure that this is as close to an ideal, user flow as we were able to get it at least. We have extensive error checking, which we absolutely need because a lot of times people just put in wrong data. And we also support analytics under MPC because we could be using Google Analytics, but obviously they don't support MPC. And for us to verify usability of the platform, we wanted to get more information about how people were using the tool. So we collect this information under MPC, and we can do things like heat maps, for example. This is kind of a difficult topic. So, okay, we've finished the communication, we built the platform. This is, again, happy to hear that Adam was talking about this. MPC has a problem of quantifying privacy and leakage in a different way that differential privacy has. And it's more of a philosophical question than a technical one. It might be that more people have done research in this space that I'm just not aware of. But it is something that we have definitely struggled with. Some of the questions are easy, right? A min-max query will reveal the data of one participant, so you probably shouldn't do them. Same thing with repeated queries on minor data modifications. We've had times where the session's open, everyone has submitted, we close the session, we look at the data, and then one more person comes in and says, oh, can we also submit our data? And we have to tell them no. Because if I have the old data and the new data, I can see what your data would have been. Some of these questions are a little bit more tricky and are more gut feeling. How many participants do you actually need to guarantee privacy? Well, it depends on a lot of factors, right? What kind of data are you collecting? What's the makeup of the participants? One of the core features of our platform is that we have anonymity. We don't know actually who participated, but it turns out it's really difficult for people running these studies because it hurts their participation rate, and they want to be able to reach out to people individually and say, hey, why didn't you participate? So we're likely changing this for the next iteration, but that also means that I have to rethink how many participants do you need, because now I know exactly if a large hospital participated versus if they were, 5 small companies. And then which algorithms are appropriate is something to think about as well. maybe median would be appropriate if I don't know who the participants are. But then what if my data set is such a makeup that I can identify, I know the makeup of your C-suite, and that row ends up being identified, so I know which company it was. Those are kind of, I unfortunately don't have good answers for it. It seems to be a lot of what if thinking and just trying to be proactive about it. Differential privacy in MPC, would be ideal if it wasn't for the fact that our data set just doesn't really work well with differential privacy, unfortunately. And then I think I'm running out of time. So really quickly, all the times we messed up. Deployment 1 for data validation. I'll skip a couple of these, and I'll go for the last 2. A lot of these issues are actually not MPC specific, but are poor planning on our end, poor assumptions, and just bad practices. The last one is interesting. One of the deployments, we had an issue with, we assumed the upper bound of the data that we were going to be getting, and we got it wrong. And so we got a call from the company saying, oh, we can't submit our data. So, we leaked their lower bound. We fixed this. We switched to submitting data in thousands of dollars for future submissions. And then at some point, someone submits in whole dollars, at least one person, because when we decrypted the data or unmasked it, we noticed that the range of values was just way off. So we emailed everyone and we said, we think someone submitted the wrong data. What we're going to do is under MPC, obliviously divide by 1,000 if the value is too large. And this was successful. We got the data in the right range, but we also leaked, the order of magnitude of at least one company, which was unfortunate. But it does show that you can recover from mistakes even under MPC, even though it's really costly. And then, some acknowledgements. Obviously, I'm not the only person working on this. A lot of people have worked on this for a lot of years. Thank you.
Thank you, Frederick. Yeah, I don't think I saw any questions on the chat. So maybe Hugh, you have any comments you want to add here?
Well, I just think this is a really interesting project. I've been watching it now for a few years as Frederick and the SAIL team have worked on it, and I think it's developing into something that's going to be used a lot more as more people find out about it.
Yeah, I think for me it was very interesting because when you had technical difficulty joining, Hugh was actually asking me whether I knew about MPC before I got pulled into this, and actually I didn't, right? So then when you gave me those pointers, I went and did some research and to understand the concept and etc. And I found that it was pretty interesting because. And then, so he and I were chatting about AI and, how when you apply AI to data, you have the same challenge, right? Because, the data is, in order to do real AI on to get some valuable information, some of the information has privacy issues, right?
Right.
So, and then how do you get around that, right? So I think that's kind of important. So, hey, Hugh.
Hey there.
So I don't see anybody. Yeah.
Are we the only ones
Looks like
participating?
I think so. I think Heidi asked us to stay last time, 5-ish minutes and see if anyone showed up. And if not, then...
We've got a few more folks watching now, if I'm reading this right. We were, I think it was last fall of 19, we were at maybe if I'm remembering the date right, we were at the beginning of trying to get engaged with you and Mayank, Frederick, on an MPC for TensorFlow or MPC for AI project, and I don't remember exactly what the planned infrastructure was going to be, but it was something in the nature of, you set up 10 models, and then you have the models participate in an MPC computation for generating results, and the net result is that it's much more difficult for an attacker to determine which data set the result came from, because you're working across multiple data sets, if I'm remembering all that right. And then you put differential privacy in front of that whole thing.
Yeah, I mean, there's definitely, if you look at the current space of academic research for MPC, I mean, there's always making sure that protocols run faster, but a lot of it is in the programming languages paradigms of how do we build things that people can actually use, and a lot of that will have to do, I think, with tooling and making sure that, I mean, there is a fork of TensorFlow that uses MPC, but still, we're definitely nowhere near the level, nor are we with differential privacy for that matter. You know, like picking your privacy budget. I know there's a talk in the next couple of weeks at a different conference that I'm attending that will be Google explaining, you know, the tools that they built for researchers to figure out how to pick an appropriate privacy budget, how to pick an appropriate epsilon, for example, which, you know, it sounds good in theory, right? But it is a very philosophical open question of how much privacy is the right amount of privacy. And you kind of determine that for your users, but maybe you're not the right, like you're obviously biased and maybe you're not the right person to make that determination. It's really the user who has to determine if they're, you know, comfortable with that amount of privacy loss or leakage. But then again, if you ask them, you know, they wouldn't know either. So it's a difficult problem to solve, I think.
Yeah. I think one of the questions I had was, while you were presenting, I thought about a couple more questions. I thought I'll ask them in this forum. One question I had was, typically, you know, customers who are in different industries like these, like healthcare, for example, right? They have to go through the HIPAA audits every year or whatever, right? So the question I have is, when they are involved in these MPC kind of projects, do you know of examples where how the auditors react to these things? I mean, what kind of data does the auditor need to be happy that you are still, you know, HIPAA compliant, right? For example.
Right. It's a good question, and I'm probably not the best person to ask it to. Mine Feria at Boston University has more experience with this. What I do know is we worked at BU with the company in the past that's active in the space of linking healthcare hubs together and sharing data. And one of the things that they had to go through was getting by, there's only 5 people, they're kind of self-proclaimed HIPAA auditors that will verify and vet your software solution to put a stamp of approval on it and basically say this is HIPAA compliant. Mm-hmm. And they ask for exorbitant amounts of money. There's only 5 of them. It's like a good old boys club where they keep, you know, themselves intact because they basically will determine who the next person is who gets the stamp of HIPAA approval. It's not a government approval. It's just they're respected enough in their field and they kind of do this for companies. Because you touch upon, you know, maybe you do collect, like in their case it was, I do collect one of the privacy identifiers, but if I combine it with other data and then mask it and have like different combinations of it, it is HIPAA compliant, or it could be HIPAA compliant, and they said, yes, it is HIPAA compliant. But of course, in the MPC side, and this is pure conjecture on my end, like I'm making assumptions here, you would cut into their business model. They have no incentive of saying, yes, MPC is a one-size-fits-all solution for HIPAA or for GDPR or for whatever the case might be, and you can use it, because that would mean that they can't certify individual software projects anymore. And that's their business model, and that's how they make their money. So I think in the end, it will be both a political thing as well as a judicial thing. You know, before this actually gets resolved, someone will test this in court, and
it's not like the HIPAA police are going to come arrest you if you don't do it right, right? I mean, it depends ultimately on somebody deciding they're going to sue someone else,
Right.
and seeing what the court, how the court interprets the rules.
Right. Obviously, the laws don't speak. That you have the 18 HIPAA identifiers, but there's no notion of even when it comes to encryption. It's like industry standard encryption or whatever the verbiage is that's used, because they don't want to go so specific and say, oh, you have to use AES, 256 GCM, whatever the case might be, because your law is going to be outdated really quickly. But at the same time, MPC wasn't on their mind when these rules were written.
Right.
So maybe it would be judged by the intent of the law, maybe more so than the letter of the law. And maybe the intent of the law is that, individual people shouldn't be part of a computation, even if the result of that computation doesn't violate HIPAA. But maybe the privacy happens, at a different level. It's not so much leaking your data. It could also be incorporating your data in a computation. I don't think that's the case, but you never know. I mean, this could go all the way up to the Supreme Court, for all I know, when it comes to those kinds of decisions. If you have enough money to, drag it out.
That's actually one of the cool things I think about how BU and Harari do their work, and I assume SAIL as well, that you have lawyers like as part of the team who are involved, who are like being proactive about this stuff and coming to the technical conferences about differential privacy and MPC, which is, I think that's pretty unique to see them involved at that early stage. It's great. And I think
we have a collaboration with the law school to talk about the effects basically of these technologies and others on pertinent legal questions.
Yeah. The other second question I had was, in terms of the algorithms, do the algorithms depend upon the domain of the topic, right? So, for example, if it is pay equity versus sexual harassment or versus something else, right? Depending upon the problem space, are the algorithms that are used different? I know everything is open source and there are frameworks available, etc., right? But how do you, in your experience, what do you find? I think that was the other question I had.
Yeah, so a lot of the algorithms are just basic statistics. When we look at pay equity, we look at aggregates and standard deviation, and I think linear regression is one of the things we would like to be able to support, because we also ask questions like, how difficult was it to collect this data? We have statistical questions or multiple choice questions. We would like to be able to link this in a meaningful way to the data. So linear regression is definitely something that we would like to support, but even though the library could do it, performance-wise, especially on the web, it's a little more tricky. So general purpose MPC has a difficulty of being too general. Everything works, but a lot of times for MPC, very specific tricks are employed to make sure that your algorithm is fast enough so that you're not needlessly computing under MPC. It's always cheaper to do things in the clear. So maybe you want to pre-compute a square of your data if you're doing standard deviation, for example. You pre-compute it in the clear, and then you submit it as a secret share. So that's kind of one aspect to your question. The second one is that one of the things I didn't really touch upon that much, but similar to the bank fraud project, private set intersection or private membership testing is a very valuable tool that is maybe a subset of MPC or maybe complementary to MPC. I'm not really sure how the crypto community sees this officially, but it allows you to do overlaps, for example, between data sets without revealing the contents of the values that don't overlap. So, when it comes to bank fraud detection or when it comes to sexual harassment, for example, one of the things that we were doing there was using a combination of Shamir secret sharing and private set intersection to see if the person that I'm reporting is basically already reported, is already in your database. If they're not, then I don't reveal anything about this data. But if they are, then now I have an extra data point, and now this looks like a serial perpetrator. And so maybe it's worthwhile for me to actually go to a lawyer or to police, because I don't want this happening to other people, any more than it already has. So there are different. I don't really know if this answers your question, but every problem requires its own solution in that sense. The one thing that I haven't really been active in is the space of artificial intelligence, machine learning. Like, technically everything is possible under MPC, but what companies are doing is resorting to custom hardware to do fast matrix multiplications for MPC, for example, because that's what you need, right? If you're doing gradient descent, then that's the algorithm that you're running. And general purpose MPC is just way too slow to encapsulate, the generality of AI under MPC.
Got it. Yeah, it's a pretty interesting space for sure.
Question. That slide that you showed, Frederick, that was all the companies that are using MPC already. Mm-hmm. Is that something, well, you said you've been working on MPC for quite a while, even just yourself. Is it like most of those companies showing up in the last couple of years, or have they been starting up more, slowly than that? Or like, are we in a period where it's accelerating? Can you tell?
I would say it's probably accelerating. I mean, the startup that I'm part of is a fairly recent startup as well. There's some names in there, like let's say ShareMind, for example, which is one of the old guard of the MPC world. They were one of the first ones with a commercial solution back in 2012 or 2013. Other companies like Unbound Tech or Enigma, they're linked to big names in the crypto space. Like, if you read papers, you'll see advisors or CEOs or CTOs of those companies show up, vice versa. And then there's a lot of smaller startups. A lot of them seem to want to incorporate blockchain for some reason into MPC, like kind of complementary to MPC, do MPC, but on top of that have a ledger of the computations that have been performed. I would say the majority isn't told in 2 years. Sorry, what's that?
Plus, you get extra buzzwords.
Oh yeah.
Why not?
Investors love. Well, you're 2 years too late probably, but investors love blockchain. So yeah, I'd say the majority of them are younger than 2 years.
Are there any people who want to join who are watching, lurking? Yeah, I think it's probably safe to say that we've reached the end of the discussion.
Yeah.
It's a really fascinating topic, and I think I really am excited about us collaborating with you on more projects, and especially the things you brought up about social good. There are so many people who want to work on social good projects and don't know where to find them. So trying to get across to people that there's really important work here going on would be fantastic.
All of our work is open source. We'd love to collaborate more.
Yeah. I think I agree with you, Heidi, on the social good aspect. I was very fascinated by that. Yep.
Okay.
Well, then.
Thank you very much,
Thanks
Frederick.
so much, you all.
Jaya, it was great. I really enjoyed the discussion.
Yeah, I enjoyed it. Thank you, Frederick, for the presentation, and I hope to collaborate with you in the future. Thank you.
My pleasure. Thanks.
Bye.
Bye-bye.